Okay, so I just wanted to show you how you could access Blackboard and get tons of stuff. On my Blackboard page, right in here, you would find what was assigned that day. Every day I make one of these things. Here's the answer key. You just have to click on that. You get the key. And then down here, you get the first video, and then down here's the next video of what we did in class that day. So if you ever miss a day or sick, please go and use this. It's the best way to stay all completely caught up. I consider that your responsibility at home. If you get sick, I'll understand if you don't have a computer, but that's pretty rare nowadays. All right, so let's go to in here. We're going to be doing polynomial long division. Well, what does that mean? That means that I am going to be doing a long division problem to see if something like x minus 1 goes into that. All right, so this is the new material for the day. I'm just going to show you what one kind of looks like. Some of you are probably bright enough to just catch this right on the very first try, but I'm guessing it's only 1 or 2 out of the whole room. So just try to see what I am doing here and what it's based on. I'm seeing if that's a factor of that. So put x squared plus 2x minus 3 here. Okay, now I say, well, what could I put here in my long division that would tell me how many times this goes into this? Okay, it goes in there x times, because x times the x makes x squared. X times the negative 1 makes negative x. And now I do the opposite of each term. I change that to that and that to that. And then these two terms cancel, and I have 3x minus 3. And I keep going. And I say what should go here. All right. That's a brief overview of what we're going to be doing. So that's all based on long division. So let's do some of that. Here's a typical problem for today again. Does that go into that? Well, I'll show you how to do these. Just pay attention, though, because this is not like super easy. Okay, long division. Do you remember back when you learned how to do, does 3 go into 22? You remember that kind of stuff? All right, you learned long division at one point, but it was a long time ago. So on your scratch paper, please, right now, copy that one down. I'm going to do a few with you, because if you don't understand them with just simple numbers, you have no hope, because these are much simpler than what we're doing today. All right, so now, and even if you never learned long division before, I know some people learn different ways. I'll show you this way. You'll be able to pick it up by the end of the hour. Does 3 go into 22 at all? Yeah, it goes in there a few times. How many times? 7. So I go 7 goes, or it goes in there 7 times. 7 times the 3, notice I go this times this, makes 21. Draw the line. Do you remember this? Raise your hand if this is familiar. All right, I'm getting 3/4 of the hands at least. Okay. Then I go opposite of this 21. Notice you don't even think about that. You think of that as subtracting it, but you do the opposite of that number. Then you add them together and you get 1. Okay, and now I say, wait a minute, does 3 go into 1? It doesn't really work, does it? So my final answer is 7, and does anybody know what to do with those guys? Yeah, somebody said it. Raise your hand. Tell me that again. Yes? Yeah. That goes over that. 7 1/3 is my answer. Now, did it go in there evenly? The answer would be no. It's not a factor. 3 is not a factor of 22 because it didn't go in evenly. But when it was all said and done, I found out what to times it by. That times that gives me 22. All right, another long division. Is 7 a factor of 83? So set this up. 7, 83. What's the first thing you ask yourself? Yes. Correct. 7 go into 8. Does it? Yes. 1 time. 7. How much is left? Well, I got to make this the opposite of 7. And then 7, 8 minus 7, or 7, 8, yeah. 8 minus 7 is 1. I bring down the 3. 13 is left. And now I go, does 7 go into 13? How many times? Once. Makes 7, and there's 6 left. And now, do you remember what to do with the last, at the end, when you don't, if it doesn't all cancel out? 6 sevenths. 11 and 6 sevenths. Are you getting this? Raise your hand if you're getting this. You remember this. Okay, good. hard to tell from you guys because you're kind of quiet. Do this last one. I'll tell you right now, it does work. So when you're at the end of the problem, you're like, oh, I can't tell if it goes in or not. It does. I'll pause this while you work that one out. So first you'd say, yeah, 18 goes into 28. It goes in there once, and I have 18. Make it the opposite. Now you got 10 left. Bring down the 8, 108. Now he told me that it's going to go in there, so it must work. So 5 doesn't work. It must be 6. Try 6. Now notice I do 6 times the 10 and 6 times the 8. 6 times the 10 is 60. 6 times the 8 is 48. 60 and 48 adds up to 108. And there's 0 left. So that means it worked perfectly. There's no remainder. So that means 18 times 16 gives me 288. So the question was, is 18 a factor? And what was the answer? Yes. All right. So now let's try this with, we don't need any more practice with numbers. Now we're going to try it with the variables. All right. I'm going to pause while I set this thing up. Okay, your first step is to figure out what number should go here so that that number times these two things, we're going to put them here. And we need, and this is important now, we only need that first term to match up. So what can I put here that will give me this times the x will give me x squared right here? Yes, an x. I put an x there. So everybody on your paper, just follow along with me and see if you can do this one step at a time. X times the x gives me x squared, and x times the negative 1 gives me negative x. Then I draw a line. And then, do you remember how on my little simpler problems, like 3 goes into 13, I go 3 goes in here, 6 times is 12, and then I always made it the opposite of that? Well, I have to do the same thing here. I have to make it the opposite. But don't just throw in a negative here. By now you should know that when you do the opposite of something that has 2 terms, you have to do the opposite of both. So this becomes negative and this becomes positive. That way it's the opposite of both. Then these two will cancel each other out just like I wanted. That's why I wanted the first term to match. And then this other one won't. But 2x plus an x gives me 3x. And then I bring down the minus 3. And now we just have to put another number here. And so I go, what times the x can give me the 3x? A 3. So I need to have a positive 3 there. I need to match it exactly. Positive 3 times x gives me positive 3x. Positive 3 times negative 1 gives me negative 3. And look at that. It matched perfectly. So when I do the opposites here, they are opposites, and these cancel, and these cancel, and I have 0 at the end, and that's crucial because that means there's no remainder, which means that I have got one that was a factor. So is this a factor? Yes. And what were the factors? That times that makes that. And what I ask you to do is write the 2 factors out. X plus 3 times x minus 1. And yes. You get that? All right, we're going to do several more before we turn you loose and assume you really have it. All right, on your scratch paper, another one. X minus 3 going into x squared minus 7x plus 12.